Hello, everyone, and welcome. My name is Tahte Perkins, and I'm a senior solutions consultant with 321 Gang. Today, we're going to dive into an interesting topic, integrating your model with CI/CD pipelines. This is a crucial step in modern software development, and I'm excited to share how it all comes together. Before we get too deep, just a quick note about 321 Gang, a SodiusWillert company. We're all about helping teams like yours achieve success in complex software and systems development. Let's take a look at what we'll cover today. We'll start by defining what GitLab is for those who might be less familiar. Then, we'll explore the significant benefits of using a CI/CD pipeline. The core of our discussion will be on the integration with UML modeling. And finally, we'll wrap up by highlighting the overall benefits of this model integration. This agenda will guide us through the process of understanding and implementing this powerful integration. So what exactly is GitLab? At its heart, GitLab is a developer-centric tool suite. It's a comprehensive platform that covers the entire software development lifecycle. This includes robust issue tracking capabilities, allowing teams to manage and collaborate on tasks effectively. A key feature, and one we'll focus on today, is its powerful CI/CD pipelines. GitLab also offers built-in security scanning, which is vital for identifying vulnerabilities early in the development process. All of this is built on modern Git-based technology, providing a highly collaborative and version-controlled environment. Think of it as an all-in-one platform for your development needs. Now, let's talk about the benefits of a CI/CD pipeline. There are several compelling reasons to adopt this approach. Firstly, it leads to faster error detection. By continuously integrating and testing code, issues are identified much earlier in the development cycle, making them cheaper and easier to fix. Secondly, CI/CD helps to reduce integration risk. Instead of large, infrequent integrations that can be problematic, continuous integration ensures smaller, more manageable merges. This also enables more frequent releases, meaning you can deliver new features and bug fixes to your users much faster. And as I mentioned with GitLab, a major benefit is the built-in security scans, which proactively identify potential security flaws throughout the pipeline. The visual on this slide really shows the flow from code commit and building to testing, review, and finally, production. It's a streamlined, efficient process. Now, for the core of our discussion, how do you integrate your modeling with a CI/CD pipeline? We're specifically talking about using a UML modeling language to generate production code. This is where your models aren't just diagrams. They're the source of your actual code. The process generally involves a few key steps. First, you create a feature branch in GitLab. This allows you to work on new features or changes in isolation without affecting the main code base. Next, you'll use the command line interface of your modeling tool. This is crucial as it allows for automation. You can script the generation of code from your models. Finally, this action will then kick off your CI/CD pipeline. The pipeline will take the newly generated code, run tests, perform security scans, and potentially deploy it. This ensures that every change to your model is automatically validated and integrated into your development workflow. Here is the brief example we have built using the IBM Rhapsody GitLab integration. I've got the Rhapsody Coffee Maker model. It's a sample C model in Rhapsody. I've checked that model into a GitLab project, and I'm going to do a quick demo of how to add a new feature to the model. So I'm going to go to my GitLab tasks. I'm going to create a new GitLab task related to this activity. I'll create a new task called Calculate Pi and assign it to me. Then I'm going to create a merge request related to it. So this will isolate my changes off into a feature branch. Again, I'll assign that to me, and I'll create the merge request. What this will do is create a new branch in the model for me called 12 add calculate pi into the repository. Now I can go over to my local Git repository, and I can go to remote fetch from origin, and the new branch shows up. Now I want to check out my local code onto that branch. I'm going to click a tracking branch and select 12 add calculate pi, and I'll click checkout. I wanted to calculate pi and click create. So that creates a new branch locally. And now I'll do a checkout to that local branch that I just created. Checkout. Okay, now I'm on a local branch. Now I'll go to Repository Explorer. Working copy. This will open up my local working copy of the repository. And you can see here's my coffee machine model. So I'm going to double click on that to open it. This will launch Rhapsody in my model. And I'm going to browse to my packages. And in my boiler class, I'm going to add a new operation. We're going to call it the new operation calc_pi. I've added the new operation. I'm going to go to the features. I'm going to add an implementation for it. Then I'm going to add some code here that's actually not going to work very well. So let's create something here that we know is going to break. It's not going to pass the compiler or the security test. So I got two character pointers. I'm going to do strcopy from B to A. And as everybody knows, that's not great C coding. Now I've got my implementation in there. I could build and run it at this point. But instead, I'm going to generate the code with dependencies. So this is going to generate the new code for that new operation that I wrote. I'm going to save it, and then I'm going to get out of Rhapsody. When I rescan my changes, you can see all the changes that were actually made to the files. I'm going to stage those changes, and then I'm going to commit them to the repository, and then I'm going to push them to the remote repository. So I push the changes over. You can see that it tells me that where it pushed them. And here's the merge request link to it, which is pretty cool. Here are my merge requests, and it starts a new pipeline. When I look at the pipeline, we can see that there's a build job. And then there's a couple of security scanning jobs. So let's see what the build job does. So the GitLab runner checked out the code. It runs the Rhapsody CL command line, and it uses a script that executes a make on the code. Then it does a compile, and then if we go back to the pipeline, we see the build job is completed. If I click on security, it displays a vulnerability in that code I just added. It did a couple of scans there. If you look at the pipeline, you can see it does display a flaw. The GitLab C code vulnerability scanner also scans for secrets that you might have embedded in the code. That's it for this quick demo. To recap what we've discussed today, GitLab is indeed a developer-centric tool. It provides a comprehensive set of features that empower development teams. Crucially, integrating CI/CD pipelines and models is not only possible, but highly beneficial. This integration allows for modern security, scanning, and automation throughout your development process, ensuring higher quality code and faster delivery. By bringing your models into your automated pipeline, you gain significant advantages in terms of efficiency, quality, and security. That concludes our presentation on integrating your model with CI/CD pipelines. Thank you for attending today's session. Feel free to contact us at 321gang to ask anything about GitLab, CI/CD, or model integration.